Here we'll talk about how to multiply a matrix and a vector. So if we start with an n by n matrix A and an n by 1 vector x, we're going to multiply AX as follows. AX is equal to x1a1 plus x2a2 up through xn an, where x1 through xn are the entries of the vector x, and a1 through an are the columns of the matrix A. So basically what we're going to do here is we're going to take the first entry of x times the first column of A, the second entry of x times the second column of A, continue this, and then add them all up. And it's important to note that we can only multiply a matrix and a vector if the number of columns in the matrix is the same as the number of rows in the vector. So we'll do this. We take the first entry in the vector, which is -8, and we multiply that by the first column of the matrix. -5, -6, -6. The next entry is a 6 times the second column. -2, 0, 7. And then -8 times the third column. -7, -2, and 1. So -8 times -5 will be positive 40. -8 times -6 is 48. And then we have another 48. Plus 6 times 2 is -12, 6 times 0 is 0, and 6 times 7 is 42. Plus -8 times -7 is 56, -8 times -2 is 16, and then -8 times 1 is -8. And now we just add things up. So the first entry is going to be 40 minus 12 plus 56, which gives us 84. The next one is 48 plus 0 plus 16, which gives us 64. And then the last one, 48 plus 42 minus 8 is 82. So this is the result when you multiply this matrix by this vector. So next we'll multiply two matrices. And we're going to do this in two different methods. So the first one relates it to multiplying a matrix and a vector. So if we have an m by n matrix A and an n by p matrix B with columns B1 through BP, then the product AB is found by AB1, AB2, all the way up through ABP. So this basically says we're going to multiply the matrix A by each column vector of B. So when we do this, we'll start by multiplying matrix A by the first column of B. So we have -8 times the first column plus 1 times the second column plus 7 times the third column. And from here, we're just going to use scalar multiplication and vector and matrix addition. So the first entry is going to say 24 plus 9 minus 28, which will give us 5. The next one says -24 minus 4 plus 35, which gives us 7. So this is the first of 3 steps. We need to do this again for every single column of B. So I have the same matrix A times, this time, the second column of B, which is 7, 8, 0. So we have 7 times minus 3 plus 3. We have 8 times 9, negative 4. And we have 0 times negative 4, 5. So this time when we add them up, I get negative 21 plus 72, which is 51. And then 21 minus 32, which is negative 11. So now we need to repeat this process one more time. This time for the third column of my matrix B. Which is 2 minus 8 minus 8. So I have 2 times negative 3, 3, minus 8 times 9, negative 4, and minus 8, negative 4, 5. So this gives me negative 6 minus 72 plus 32, which is negative 46. I then have 6 plus 32 minus 40, which is minus 2. So now that I have all three of these, I have my answer. So my final answer, the first column will be 5, 7. The next one will be 51 minus 11. And the last one will be minus 46 minus 2. So this is definitely a very long process when you do it in this method. Fortunately, there is a second way to do it that may make it a little bit easier. So this time, when multiplying an n by n matrix A and an n by p matrix B, the entry in row I and column J is going to be found by multiplying the ith row of A by the corresponding entries in the jth column of B. So I'm going to multiply rows and columns. So for this one, I'm going to start with the first row of matrix A, the first column of matrix B. Negative 4 times 5 is negative 20. Negative 3 times 0 is 0, and 3 times 7 is 21. Moving on to the first row, second column. Negative 4 times 5 is negative 20. Negative 3 times 5 is negative 15. And 3 times 8 is 24. First row, third column. Negative 4 times 6 is 24. Negative 3 times 8 is minus 24. And 3 times 0 is 0. So that's the end of the first row, and we move on to the second row. So now we move on to the second row, first column. Negative 3 times 5 is minus 15. Negative 2 times 0 is 0. And 2 times 7 is 14. Second row, second column. Negative 3 times 5 is minus 15. Negative 2 times 5 is minus 10. And 2 times 8 is 16. Second row, third column. Negative 3 times 6 is 18. Negative 2 times 8 is negative 16. And 2 times 0 is 0. And now we move on to the third row. Third row, first column. 3 times 5 is 15. 2 times 0 is 0. And 4 times 7 is 28. Third row, second column. 3 times 5 is 15. 2 times 5 is 10. And 4 times 8 is 32. And finally, third row, third column. 3 times minus 6 is minus 18. 2 times 8 is 16. And 4 times 0 is 0. So at this point, we just need to simplify things. Negative 20 plus 0 plus 21 is 1. Negative 20 minus 15 plus 24 is going to be negative 11. 24 minus 24 plus 0 is 0. Negative 15 plus 0 plus 14 is negative 1. Negative 15 minus 10 plus 16 is going to be negative 9. 18 minus 16 plus 0 is 2. 15 plus 0 plus 28 is going to be 43. 15 plus 10 plus 32 will be 57. Negative 18 plus 16 is minus 2. So now I have the final answer. So let's do another one. You'll notice this time the only difference is that I changed the order that I'm multiplying things in. So let's see how this affects it. First row, first column. Negative 5 times 5 times negative 4 is minus 20. 5 times negative 3 is minus 15. And then negative 6 times negative 3 is minus 18. First row, second column. 5 times negative 3 is negative 15. 5 times negative 2 is negative 10. Negative 6 times negative 2 is minus 12. First row, third column. 5 times 3 is 15. 5 times 2 is 10. And negative 6 times 4 is minus 24. Moving on to the second row, first column. 0 times minus 4 is 0. 5 times negative 3 is minus 15. 8 times 3 is 24. 0 times minus 3 is 0. 5 times minus 2 is negative 10. And 8 times 2 is 16. Third column, 0 times 3 is 0. 5 times 2 is 10. And 8 times 4 is 32. Moving down to the third row, 7 times minus 4 is negative 28. 8 times minus 3 is negative 24. And 0 times 3 is 0. 7 times minus 3 is minus 21. 8 times minus 2 is negative 16. And 0 times 2 is 0. Finally, third row, third column. 7 times 3 is 21. 8 times 2 is 16. 0 times 4 is 0. And now we will simplify this. Negative 20 minus 15 minus 18 is minus 53. Negative 15 minus 10 minus 12 is minus 37. 15 plus 10 minus 24 is 1. Negative 15 minus 24 is 9. Negative 10 plus 6 is 6. 10 plus 32 is 42. Negative 28 minus 24 is minus 52. Negative 21 minus 16 is negative 37. 21 plus 16 is 37. So it's very important to note that even though I used the same matrices, my product was different this time. And this comes from the fact that I switched the order on them. So this is a 3 by 3 times a 2 by 3. In my definition of matrix multiplication, I said that the first one should be m by n, and the second one n by p. So this is very important because these two inner numbers should be the same. The fact that they're not here means that this is undefined. So finally, a few properties of matrix multiplication along with some warnings. So matrix multiplication is associative. I can move around parentheses. However, I can't switch the order as we saw in our example. So as long as A is first, B is in the middle, and C is last, you should be okay. You also have a distributive property, A times B plus C is equal to AB plus AC. And we have a second one, B plus CA is equal to BA plus CA. So like I said, order is very important here. The fact that the A is on the left side of the parentheses means it should be on the left side of the multiplication on the right-hand side. The second distributive property, A is on the right-hand side, so it should also be on the right-hand side on the other side of the equal sign. Property 4, R times AB is equal to RAB, which is equal to ARB. So this just says if you're multiplying by a scalar, it doesn't really matter when you multiply by the scalar. And then a few warnings. AB does not mean B is equal to A. We saw an example of this. AB equal to AC does not necessarily imply that B is equal to C. There are certain cases where this is true, but we need to know more information. We cannot just use cancellation. And finally, AB equal to 0 does not necessarily mean that either A is 0 or B is 0.